Today we're going to talk about properties of parallelograms, continuing on with Chapter 6, Section 6.2, properties of parallelograms. Just looking at the word parallelograms, what's something that pops out at you?
Parallel.
Parallel. What's going to be parallel?
Lines.
The lines, the sides. Okay, so we're talking about shapes with parallel sides. Okay, properties of parallelograms, there are 4 of them. Now some of these you should probably have already recognized or known. Some of these might be new. A parallelogram is a quadrilateral with 2 pairs of parallel sides. All parallelograms, such as parallelogram FGHJ, have the following properties. The opposite sides are congruent. That's something you probably should have recognized already. Opposite sides are congruent. The opposite angles are congruent. Well, if opposite sides are congruent, opposite angles are congruent. That makes sense. Consecutive angles are supplementary. Now, why is that true? Now, remember, opposite sides are parallel, right? So if these sides are parallel, what type of angles are these right here?
They're like the same.
Same what?
Same.
So those are same side interior angles. Remember talking about same side interior angles back in Chapter 3?
Yeah.
Same side interior angles are supplementary? Well, that's why this is true. Consecutive angles are supplementary because same side interior angles are supplementary. Okay? And then the last one, the diagonals bisect each other. Heston, what's it mean to bisect? Okay, between where? Middle. Yeah, bisect means cut in half, so it goes through the middle. So if the diagonals bisect each other, they go through the middle of both of each other. All right, so those are the 4 properties of parallelograms. As you look through those, again, you probably should be able to recognize a few of those. And after talking through them, it's like, well, that makes sense. So let's use those properties. Oh, not parabolas. These are parallelograms.
Oh, those suck.
Okay, so number 1 here. I want to find each measure. I want to find AB. So as I look here, I want to look at AB. Oh, let's go with Chris. What do you think AB is going to be?
10 centimeters.
Why is it 10 centimeters?
Because it's parallel to DC.
Yeah, it's parallel to CD, and the opposite sides are also going to be what?
Parallel.
They're parallel, but they're also what?
Congruent.
Congruent. In a parallelogram, opposite sides are?
Congruent.
Congruent. Looking at this, it doesn't ask me, but Trent Bannister, what's BC going to be? BC would be 14 centimeters. Why? Because opposite sides are congruent. Number 2, I need to find angle D. If I were to look right here, angle D. Quinn, what would angle D be? 70 degrees. Why? Yeah, those 2 angles are supplementary. If angle D is 70 degrees, what's angle B going to be, Claire? Angle B, what would angle B be? Because opposite angles are congruent, right? And then what about angle C? What would angle C be, Luis? And because opposite angles are congruent. And if you look here, are these supplementary? Are these supplementary?
Yep.
Are these supplementary? Yeah, so again, consecutive angles are supplementary in parallelograms. Take a couple seconds to try these 6 on your own. All right, let's walk through these. The first one, number 3. Shh, quiet down here. Spencer, number 3, ML. What's ML going to be? 12 meters is correct. 4, LP. Katie, LP. 10 meters. Number 5, angle LPM. Colton, LPM. What's that going to be? Why is it 62 degrees? I agree. Huh? What type of angles are these right here?
Like opposite exterior.
Not exterior, but alternate interior angles.
Same thing.
Those are alternate interior angles, means they're congruent. LN, what's LN going to be, McCool?
I got the measure.
LN?
LN.
Well, it's not Is it 41? I don't know.
What'd you say?
It's 41 up there.
LN, right here.
Oh. Yeah, I don't know.
What's it, Heston?
18.
Yeah, it's 18.
He said 41. 41.
Now, if this one's 9, if this one's 9, that means this one's going to be 9, because remember it bisects it, cuts in half.
I looked at 32 for some reason. I don't know why.
So you took 9 and 32?
Yeah.
All right, quiet down. 7, Becca, MLN. 32 degrees. And again, that would be alternate interior angles there. And then QN, what's QN going to be, Blake? 9, yeah, we kind of already talked about that already. Nice job. Next part here. Same idea. I can use properties of parallelograms to solve. or to find measures. For example, let's look at angles X and W. If they're consecutive angles in a parallelogram, consecutive angles are what? They equal 180. They're supplementary, right?
Yeah.
So what would I do with 4x and 7x plus 15?
Add them together.
Add them and set equal to
80.
180. So I add them, set equal to 180, and then I solve. X equals 15. You plug that each back in, you get 60, and I think that one is 120 degrees. So you can use the properties to solve. So let's look at 9, 10, 11, 12. So I need to find CD and EF. What do I know about these two sides right here?
They're parallel.
They're parallel, but they're also going to be
Equal to 180.
they're also going to be the same. There's nothing about sides, but
Yeah.
the sides are going to be the same. So how would I set that up? I would say
4W plus 8
yeah.
equals
4W plus 8 equals 5W plus 1. 4W plus 8 equals 5W plus 1. When I work that out, I get W equals 7. So I plug that back in, and CD is going to come out to be 36. EF comes out to be,
36.
again, recognize they are the same. And then I need to find angle F and angle E. Well, what do I know about these two angles right here?
They're supplementary.
Supplementary. So what am I going to do? I'm going to
Add them, set equal to 180.
add them, 3Z
12Z
plus 9Z minus 12 equals 180. 3Z plus 9Z is 12Z. Minus 12 equals 180. Add 12 to the other side, you get 12Z equals 192. When you do that, you get Z equals what? Z equals 16. Plug that back in. Angle F is going to come out to be
I don't know.
3 times 16? 48 degrees.
48.
Then you take Z and you plug it in up there.
48.
And
No, 48.
the other one angle is going to be 132. You plug 16 back in for both.
I was talking about number 9.
Oh, yeah, 9. Yeah, 9 you plug 7 back in for W. Yep. So that's where you can find the missing angles or sides and solve. Take a couple seconds, try these two on your own. All right, Reed, walk me through this one. What'd you do?
Set add 10 and plus 8 equals 180.
Because they are what?
Supplementary.
Because they're supplementary, right?
Yep, so 18n equals 180. And then you get n equals 10. So it's 80.
So 100 degrees and 80 degrees. Now it doesn't ask me, but how would I find PQ and SR here? How would I find those two?
Set them equal to each other.
You can set them equal to each other and solve. When we do that, you get X equals what?
3.
So this has got to be 6 and this has got to be 6. Very good. All right. Last thing we'll talk about is a couple more properties of parallelograms. We can look at this in a coordinate plane. Okay. For example, 3 vertices of parallelogram RSTV are R is 3, 1, S is negative 1, 5, and T is 3, 6. You can find the coordinates of V. Now, what do we know about parallelograms? Their opposite sides are... Opposite sides are what? Parallel. Opposite sides are parallel. So in a coordinate grid, I can just find the slope. I can do the rise as run. Because they got to be the same, they got to be parallel. So what do they do here? They find the slope of S to R. The slope from S to R is down 4 over 4, right? So to find V, I go down 4 over 4. And there's V right there. Connect it, and I have my parallelogram. Now, here's a common mistake students make. A lot of times they don't recognize where V has to be. Does everybody see where V is in the label?
Yeah.
V is like between R and T.
Yeah.
It's across from S, right? Sometimes people are like, well, I want V, down here because I want this to be a parallelogram. Now let's think about that. Is that a parallelogram? Oh, wait, I had it off wrong. My bad. Should be right there. Is that a parallelogram technically? Yeah, that's technically a parallelogram. But is that RSTV?
No.
No, that's RVST. Does everybody see that? So you have to make sure you go in the correct order. You cannot just put a random point out there and make a parallelogram. You got to go in the correct order for that specific parallelogram. So there is only truly one correct answer. So let's look at these problems. 3 vertices, parallelogram GHIJ. G is 0, 0. H is 2, 3. And J is 6, 1. So I have G, G, H, and J. Now if you notice here, it's G, H, I, J. Where should my I coordinate fall between?
H and J.
So should it fall down here somewhere?
No.
No, it should fall
Up there.
somewhere up here. Does everybody recognize that?
Yeah.
Because it's G, H, I, J. I has got to be between the H and J. So I just need to find the slope here. Well, let's find the slope from 3 or from G to H.
3, 1.
Rise over run, what do I get?
Up 3 over 2, right?
I up 3 over 2, right?
Oh, yeah.
Gives me a slope of 3 over 2. So now I'll do this for J. If I go up 3 over 2, I would be located right there. And what are the coordinates of I going to be? Anybody what's the coordinates? 8, 4.
Yeah, 8, 4.
The coordinates would be 8, 4.
So how do you know like where?
How do I know what? I'm just finding the slope. So for instance,
How do you know which point you go off of?
Yeah, that's what I was gonna ask.
well, I could have done GJ. Like I could have done GJ. And then I'm going to do the opposite coordinate up there. So from H, I'm going to go up 1 over 6.
So you really just.
You just want to do the opposite side then. Does that make sense, Reed? So I could have done, I did GH, right? Or I could have done GJ. Either way, I get myself to that coordinate.
Okay.
Which one can I not do? I just can't do G to J, right?
Wait, so you wouldn't even,
Or J or H to J.
you really wouldn't even have to do the slope. You could just go from G to J and you could basically figure it out.
You could. I'd still find the slope.
Well, not until.
I'd still find the slope. Yep. So let's try this one. Now this one, my grid's kind of off a little bit. So I'm going to make this my axes right here. So this is right here, 0, 0. Just so we can work this out. So that's the coordinate 0, 0 right there. So I need to plot A. A is 0, 6. So there's A right there. B is 5, 8. There's B. C is 5, 5. There's C. And I need to find D. Now recognize it's A, B, C, D. D is after C. So I have A, B, C. Where should D be at?
Between A and C, somewhere over there.
D needs to be down here, right? Okay, so let's think about it here. Let's do the slope from B to C. What's the slope from B to C?
Down 3.
So from A, what am I going to do?
Down 3.
Down 3. And if I go down 3, where's it at?
Right there.
And the coordinate is 0, 3. And I have a parallelogram right there.
How many of these? We have a lot of these.
Maybe. Do you see how I can do it? I can do it from A to B too. If I want to do it from A to B, I'd go up 2 over 5. Well, from D, I'd go up 2 over 5, and I still get to C. Okay, either way you work it out, it's going to be just fine. Last problem. Take a couple seconds, try this one on your own. On this one now, I'm going to make this my axes. Just again, we're off a little bit. Make this your axes. So here and here. And even like that, you're going to be off just slightly. But make that coordinate 0, 0. All right, take a couple seconds, try this one on your own. All right, let's walk through this one. So first thing I'm going to do is I'm going to plot K. K is negative 4, 7. So K is right there. L is 3, 6. So 3, 6. L is going to be right there. M is 5, 3. So M is just slightly off my grid over here. M is 5, 3. I need to find N. So it's K, L, M, N. Would N be somewhere like up here?
No.
No, N's got to be somewhere down here, right? So Reed, how'd you work this one out?
I bought it, or I did it just LM.
So you went down 3 over 2. So from K, I'm going to go down 3 over 2, right? So do you get a coordinate about right there? And that's going to be N. And if I were to map it out, does that give me a parallelogram? Yep. What's the coordinates there, Reed? What were the coordinates?
-2, 3.
Is it negative 2, 4?
4.
Negative 2, 4. Nice job.
I didn't actually do it on the back, so
Okay. Does everybody see how we do that then? There you go. Here's your assignment.